Welcome to Safety is Everywhere YouTube channel. Dear friends, don't forget to subscribe this channel and share the link with your safety professional friends.
Hello everybody, good day. Today we will discuss accident data analysis regression. In last class you have seen the accident data analysis using control charts. Before that we have seen the concepts of accident investigation, the data to be collected during investigation, as well as there are different recommendations. So, today we will discuss regression. It is a very general technique, otherwise I can say generic technique for data analysis, need not be that limited to accident data analysis. So, as a result any regression lecture will be helpful to understand accident data analysis issues using regression. So, what we will discuss today? We just discussed today the concept of predictive analytics, and then what are the different methods used in prediction, and then we will discuss on regression, and I will show you some of the softwares which are used in prediction or predictive analytics. So, predictive analytics is basically the practice of extracting insights from the existing data set with the help of data mining, statistical modeling and machine learning techniques, and using it to predict observed or unknown events. Identifying cause-effect relationship across the variables from the historical data, discovering hidden insights and patterns with the help of data mining techniques, apply observed pattern to unknowns in the past, present or future. And this is the steps what is given in SAS, that process cycle of predictive analytics. So, first you define the objectives, then data preparation, modeling, development, deployment, and then your model monitoring, and this is what is the predictive analytics process. Okay. So, just let me get the pointer here, so that we will be able to write something. Okay. So, fine. So, let us see next that what are the different methods. So, you will find out that there are a large number of methods under different groups of prediction methods. One is regression, classification, time series forecasting, association rule mining, clustering, text mining, and again under regression some of the techniques, under classification some of the techniques, under forecasting some of the techniques, under association rule mining techniques, clustering techniques, and your text mining techniques. Okay. So, we will not be able to complete all those things. The purpose of prediction is given to you, but any one of the class of techniques will be useful here. So, today I will discuss regression, and then we will discuss also classification. Okay. So, what is regression? So, pictorially if you say regression, there will be two kinds of variables. The one will be dependent variable, another will be set of independent variable. Dependent variable is one that depends, whose values or whose occurrence which depends on the independent variable, which are basically affecting this. So, this can be taught in terms of also sometime like this, these are the causes and this is the effects. Okay, if sufficient information available from cause and effect relationship point of view. So, then from the safety or accident data analysis point of view, suppose you want to predict incident rate, and which is y is incident rate, with the help of input variables, what is basically the safety initiatives. So, different safety initiatives are taken in the industry, and also every year or every month there is incident rate data. So, you want to see the relationship between the incident rate and safety initiatives taken, then you can go for regression analysis. Okay. And in that case, the regression will ultimately talks about the relationship between incident rate and safety initiative, where incident rate is function of safety initiatives. So, incident rate is the dependent variable, and safety initiatives in terms of different initiatives like your inspection, like training, other things. So, those are basically responsible for the value or incident rate what you are observing. So, in general, this is the equation. Suppose there are one dependent variable, 3 independent variables x 1, x 2 and x 3. So, then the linear regression equation will be y equal to beta 0, beta 1 x 1, beta 2 x 2, beta 3 x 3 plus epsilon. Suppose if there are p number of variables, suppose x p, so then what will happen? This will be extended to x p, beta p x p. Okay. So, if you want the more detail about this regression analysis, so then I have a series of lecture also under applied multivariate statistical modeling, that NPTEL lecture series on multiple regression, multiple linear regression. So, you may go through those videos also. Today, we will not discuss in of that depth, we will just show you the application of regression in safety data or accident data analysis. Now we will see that suppose we are interested to know that what is the dependent variable is number of injuries per month, number of injuries or incident per month, and suppose inspection is one independent variable, training is another, and unsafe acts another. So, hypothetically we are we will collect data, but if good inspection for hazard identification is practiced and hazard removal is practiced, it is quite possible that this will ultimately lead to less number of incident per month. Similarly, if people are competent enough, based on through training their competency level is improved, then they will be less involved in accidents. And also, if you unsafe acts is more, then it is a chance that the NOIM will be more. If it is unsafe acts are committed unsafe acts are less, then that will be big. Maybe what happened, we are assuming that these three are independent, but training and unsafe acts number one, so there may be some kind of correlation, but for the time being we are assuming that they are independent. So, this is dependent and each of them are independent. Then let us assume this data. Suppose we have collected 30 data points, 30 data, and then number of incident per month, then inspection in some, it may be number of inspection, training may be number percentage of people trained or number of people trained, and unsafe acts, number of unsafe acts identified. Means what I mean to say, these are the variables which will be measured using appropriate measurement scale. For the timing, you please understand that okay, this kind of data are available and you want to know what is relationship between NOIM and inspection, training and unsafe acts. These data are not real data, they are basically hypothetical data. So, you want to fit the equation. Then first everybody will be interested to see that as NOIM is the dependent variable, whether the inspection, unsafe acts and training they have any linear relationship or not. The best way to start with the use of scatter plot. Scatter plot basically having two axes, this axis and this axis. So, here x axis is inspection and y axis is NOIM, which is number of incident per month. So, if you see the observation plot, so there is a decline trend and that decline trend is represented by the straight line. Similarly, for training also there is a decline trend, and for unsafe acts it is increasing trend. Okay, but if you see the data from training and NOIM, that see these are scattered, so scattered, maybe the best straight line what is fitted here, that may not be a significant fit or may not be able to explain much of the variability in NOIM. Nevertheless, this plot ultimately tells you, yes, there are some linear relations and that can be captured through linear regression. So, first is scatter plot between dependent and all independent variables. So, then there is the mathematics behind it. So, I will not discuss the mathematics here. So, you do not require to know also the mathematical details of it, but for the time being only you please keep in mind that this is what is the general form. I basically stands for the observation. So, if you have we have 30 observations. So, n equal to 30 and this is the equation algebraic form and this is the matrix form of the regression. And then when we are writing in matrix form, so that time basically the y n number of observation, x first is the intercept for n number of ones, then the variable x 1, variable x 2, like variable x k, k number of variables are there. If it is p number of variable, you will be ended with by p number of variables. So, as there are k number of independent variables, so and with intercept, so there are k plus 1 number of the coefficient between dependent and each of the independent variables. So, that is to be estimated, which is basically the talking about the relation between a dependent and independent. So, that is represented by beta and this is error term. So, then the ultimate aim will be to minimize the sum total of errors. So, when you fit the model and then the predicted value or fitted values and the actual value, the difference will be considered, that is the error, and then all sum of all differences, the squared differences need to be minimized, and that is what is the least square function. So, if you minimize this, so ultimately you will get a matrix equation like this, where this equation gives you the estimate of the parameters. So, using software you can get like Minitab we have used, and you will get that NOIM is 7.65, that is beta 0, which is basically the intercept, then minus 0.53 into inspection, minus 0.23 into training and plus 0.67 into unsafe acts. So, that means if inspection increases, NOIM means decreases, training is better, NOIM decreases, unsafe act is more, NOIM will be more. So, that is quite logical, and although the data is hypothetical, but it is giving you conceptually correct result. So, from mathematics point of view, everything is given here. If you want more mathematics, see my that NPTEL lecture on multivariate, applied multivariate statistical modeling, applied multivariate statistical modeling. Regression series, regression is there. Okay. So, we are talking about only linear regression, non-linear regression we are not talking about here. Then you see that the regression can be done using Minitab or any software. There are many software. So, if you want to use Minitab, so open Minitab, go to statistics, select regression, then there will be variable selection. One is response, another one is predictors. Under response you select NOIM, under predictors you select these three. Then you can select graphs, residual plot and others. You can say the fit intercept, others if any, then click OK and results and graphs will be displayed. Okay. So, this is basically the steps using Minitab. Now, if you want the snapshot, you see that Minitab snapshots given here. So, now ultimately when you are going for that stat, then regression, then ultimately you have to put the response values here, then what are the predictors you are putting here, then what are the plots you want, and there are other options also. You just click and you will get, and this is what is the first part is the data, second here the coefficients, and here the predicted or fitted values are given, and also some errors are given there. Okay. So, if you collect data, use Minitab and you will get the solution to regression equation. Okay. Exactly that one we have done here. So, for our data, so what are the issue here? Issue is that our dependent variable, you know, NOIM, independent variable inspection, training and unsafe acts. So, their contribution in terms of sum square given here, and their degrees of freedom are also given there. So, we will not discuss degree of freedom, you just follow some book. And so, then what happened first is that whether the model is fit to the data or not, linear regression. So, you use R square, adjusted R square and ANOVA table, these three measures we will use. So, R square is here 77.1%. So, R square talks about that what is the proportion of variance of the dependent variable is explained by the independent variables, okay, or by the model, regression model. So, what are the proportion of dependent variable is proportion of variance of dependent variable is explained by the regression model. Now, this R square is sensitive to the sample size. So, adjusted R square is computed, which is basically insensitive to sample size. Sample size means number of observations considered for the model fitting. So, adjusted R square also 74.5%. So, it is considering the accident data, it is a good figure. So, we can say the model is a good model because it is able to explain 77% of variance of the dependent variable. Another one is the analysis ANOVA table. ANOVA table having the source of variation. So, and then source is model, then error, these two. Then the model your F value is 29.20. It is basically hypothesis test that whether all the independent variables are insignificant, they are not contributing to the prediction or to the explanation of the NOIM y variable or not. Okay. And then it is 29.20, it is a large value in comparison to the theoretical value. So, this value to be compared with theoretical value, and the theoretical value ultimately your model degree of freedom is 3, error degree of freedom is 26. So, then the theoretical value will be 3, F distribution has 2 degrees of freedom, one is numerator, that is 3, and in denominator degree of freedom. Then you consider a significance level which is alpha. Alpha is usually 0.05, which is talking about the error in accepting the hypothesis. Okay. So, what happened this value, if I put this equal to F 326 0.05. So, you will get a value which will be much less than this value. So, that means it talks about that the model is fit to the data. So, that means linear model is a fit. So, this is the first thing. Then once the data is fit to the model, then you have to check whether the parameters, the coefficient values they are significant or not. So, how many coefficients are there? There are 4 coefficients, one is constant, intercept, then the first independent variable, second independent variable, third independent variable, or as such k independent variable. Then if you see the coefficient is 7.65, then this is this we all know this. Then their standard error is also computed, and then the t value, that is the t statistics is used here, and corresponding p values are also given. Means as t value is for 3.48, so it says that the intercept 7.65 is significant with probability value 0.002, means considering this is the influence of the intercept. So, then you are committing only 0.002, that is error probability. Okay. Similarly, inspection the value contribute, other way I can say the relationship value is minus 0.53. So, that is having only 0.009 probability of that not having this value. So, similarly for this and this. So, from this parameter test also what we are finding out? We are finding out all the parameter including intercept, they are significant. So, that means the regression model is accepted from adequacy point of view, from parameter test point of view also. Okay. So, you can use this model for prediction purposes. Please keep in mind the data what I have used here, these are hypothetical data. When you collect the real data, you may find problem that R square is not adequate. Some of the coefficient values are positive, but where in from concept point of view it should be negative, and many of the coefficient will not be significant. So many issues will be there. So, that requires your in-depth knowledge about regression analysis. Okay. Then I just finish this with the interpretation here. So, what is the interpretation? So, we have accepted this model. So, then if this negative relationship is justified, this is negative, trend is negative, this is positive, justified also. Now, what happened? This is basically talking about training and inspection together with NOM, some cube plot we have shown you. So, the interpretation is that if you improve the training, obviously the number of incident per month will be reduced, improve your inspection, that will also reduce, and if you reduce the unsafe acts, then your number of incident per month will also reduce. Okay. So, that is the way you have to understand the regression things. So, there are many software which can be used like Python, SAS, Minitab, Weka, RapidMiner, SPS, Minitab. So, what MATLAB, StatSoft, there are many more things are there. So, open source software like R is very famous, Python is also very famous, and if you see that commercial software like SAS, that SPSS, Minitab, MATLAB. So, all those. So, these are the software, StatSoft, etc. These are the software which will help your analysis easier, because you do not require to understand in-depth mathematical treatment of regression. Okay. So, that is a good thing to happen. So, thank you very much. I hope that you understand. What I try to tell you here is that if you have data, then data consists of pattern plus error. This pattern can be predicted. There are a large number of prediction models. One of them is regression. So, if you use regression, then there are the different steps. So, regression can be linear, can be non-linear, linear and non-linear regression. So, we have seen the multiple linear regression only, multiple linear regression. So, there the steps is that you first conceptualize the dependent and independent variables, then collect the relevant data, then understand the use software, understand the mathematical basis or basic mathematics, put the data into the software, and then you will get a regression equation. then you have to find the fitness of the model through R square, adjusted R square or F test, you can do that. Then you do the test of parameters, that means each of the independent variable coefficient values to be tested using T state. If all those things permit you that the model is fit and parameters are significant, then use this model for prediction purposes. So, as if you have a model like y equal to beta 0 plus beta 1 x 1 like this. So, then a new y new given x new independent observation related, then you will be able to find out that what will be the new y. So, that is nothing but suppose you have developed a model considering last 5 years data. So, they may be in monthly data, maybe next month what will be the number of incident in the plant for which you have considered, then feed the values like training value, inspection value and unsafe acts value in the equation, and then the equation will give you what will be the NOIM or number of incident per month for the next month or subsequently in other months also. So, that is the way you have to use the model. Thank you very much.